Okay, so I think that in this video we are going to wrap up everything that we learned from video 4H. 4H is when I was sliding bricks on inclines, and we're going to kind of wrap that up. Now, and what I want to talk about, I want to look at this diagram one more time. And what we have here is we said that force gravity pulled down at 16 newtons, force normal pushed up perpendicular to the surface at 14.8 newtons, force friction pointed up the incline parallel at 3.7 newtons, and that left a gap of around, if you sort of average those out, of around 2 newtons, and those 2 newtons caused the brick to slide down the incline. So the question is, what happens if I lowered this incline down? What would happen is, if I lowered that incline down, I would find that force normal would swing up this way. Force normal would swing up closer, and it would get larger. So force normal would get larger, force friction would get larger, and eventually that gap would close down to nothing. And sort of theoretically, right at the point where that gap between these three vectors closes to nothing, that would be like the last thing that I showed in 4H, which was where the brick was kind of halfway between sliding and sticking, where it just didn't really know whether or not it wanted to stick to the surface or whether it wanted to slide down the surface. So we're going to do a quick calculation to figure out what angle that would be. Okay, so let's get back. And we're going to have some angle here. And we're going to have force gravity, and then we're going to have force normal. We're going to call this force parallel, and we're going to say force normal equals force gravity cosine theta, and we're going to say force parallel is force gravity sine theta. Those are the same thetas. And what we want now is force parallel is going to be this dummy force. It's not a real force, and it points down the incline. But we have this real force, actual force, so I'm going to put fake next to force parallel. Now we've got force friction, and that's real. Okay. So, if the brick is right on the edge of sliding down the incline, but it doesn't quite do it, we know that that means that force friction is approximately equal to force parallel. So that means that force friction is approximately equal to force gravity sine theta. Now, we know from this equation we have mu equals force friction over force normal. That's a big equation from this chapter. So that means mu, in this specific case, not for general cases, not for any old case, but right exactly where this, I'm going to call this theta critical. And we're going to call theta critical other things later times. But basically that is just the angle where the thing starts to let go and slide down on its own. in that case, force friction is approximately equal to Fg sine theta, and force normal is always going to be Fg cosine theta, and so mu is going to be sine theta over cosine theta. And if you understand your trigonometry a little bit, you will know that mu is equal to, wait for it, tan theta. Okay, so now that angle, I can figure out that angle is the inverse of mu, the tangent inverse of mu. And I figured out earlier, way back in the game, that my mu was 0.25 several videos ago, and that is going to give me shift tan 0.25, 14 degrees. Okay, so I wasn't really able to measure that, but it all sort of comes together that when I had the angle at 22 degrees, the brick was absolutely definitely sliding down the incline. And obviously when if I just have the brick sitting on a flat tabletop, it's not going to slide at all. So somewhere between 0 degrees and 22.3 degrees, I should have that critical angle where it just is on the balance between sliding and not sliding. And so I would say that it's reasonable to come up with 14 degrees. That's all I have to say in that video.